Welcome and thank you all for attending the first ever online webinar about the University of Nevada College of Engineering programs for admitted students. My name is Indira Chatterjee and I am the Associate Dean of Engineering and also a professor in Electrical and Biomedical Engineering. And I will be serving as the moderator for this webinar. I would like to start off by introducing the Dean of Engineering, Dr. Manos Maragakis, who will give you a short introduction. Dean Maragakis.
Thank you, Indira. My name is Manos Maragakis. I'm the Dean of the College of Engineering, and I would like to welcome, on behalf of all of my colleagues, welcome you to this event this afternoon, and thank you for participating. We have assembled a panel of exceptional faculty that will be able to answer your questions and make this very important transition of your life as smooth as possible, and I want to thank them for their participation. The College of Engineering is guided by its strategic goal to offer our students what I call a globally competitive engineering and computer science education. We want our graduates to be able to be hired by anyone, anywhere across the nation. At the same time, we want to produce the most competitive workforce for our local, regional, and national industries. And to accomplish these strategic goals, we have a very systemic approach. We start from recruiting. We reach out to elementary schools, and then we go to middle schools, high schools, and today it's an event which is towards the end of the recruitment effort. And after the students come in, we are dedicated to their success. We have state-of-the-art curricula that have been recently compared to curricula of other programs across the nation. We offer the students accelerated programs like 5-year BS MS and 5-year BS MBA in all the degrees. And we have very focused minors to capture the interest of the students and assist them with employment. We have an advisement center with very talented advisors, and I would like to encourage all of you to get advised as soon as possible. We have a tutoring center for the students that face challenges during their studies. And we have career services that will assist the students to find internships and will assist them with permanent employment as they are close to their graduation. The College of Engineering, even during these very tough times, has exciting news to report. We are the highest numbers of all of our performance metrics. And our new 100,000 square foot engineering building is close to completion. It's scheduled to be completed this summer, and we are going to take occupancy in the fall of 2020. All of you will have the opportunity to be educated in state-of-the-art classrooms and laboratories. And our faculty are dedicated teachers, at the same time first-class researchers. We are a research-based program, as are all the competitive schools of engineering across the nation. And even these times, they are doing state-of-the-art research, and some of them are doing research related to COVID-19 issues. So I would like to thank you for participating, and I would like to give you a warm welcome to the College of Engineering, to tell you that I am absolutely confident that you'll get a first-class education that will shape your professional careers for many years to come. So thank you. Indira, back to you.
Thank you, Dean Maragakis. We will now start with a panel of 5 faculty from our 5 engineering departments. I will ask that each panelist introduce themselves and make a short introductory statement about themselves and the programs they represent. We will start with our panelist from the Department of Civil and Environmental Engineering, Dr. Ryan.
Thank you. Yes, my name is Keri. I'm an associate professor in civil and environmental engineering. Civil and environmental engineers generally focus on the design, construction, and management of the civil infrastructure. What is a civil infrastructure? A lot of people think of buildings, but it encompasses a lot more than that. Our transportation systems, our energy distribution systems, our water and wastewater distribution and management systems, sewer, land development, and management. So if you get a degree in civil engineering, if you enter our program, you have a choice of one of two degrees, either civil engineering or environmental engineering. If you get a degree in civil engineering, is a general introduction to all of those aspects that I just mentioned. If you choose environmental engineering, it focuses more specifically to issues pertinent to the environment, water and wastewater treatment and air quality, etc. As far as why get a degree in civil and environmental engineering? There will always be a need, and there always is a need. Of course, in a strong economy, when construction is lively, there's more of a demand, but even in a slower economy, there's a need for civil and environmental engineers. And when we talk about our program, one of the things we like to point to is a frequent statistic given by the Bureau of Labor Statistics that in general predicts strong and consistent growth in this area. So as far as me specifically, I focus on structural engineering, and for undergraduate classes, I teach structural analysis, which is a required course for civil engineering that most students take in their junior year. And I also teach an advanced analysis class, which is a technical elective that you'll see in your senior year if you choose to take it, and also a timber design course, which is also a technical elective. I was asked to talk a little bit about our research program. We have a variety of strong research programs in our department. The structures and geotech group focuses on earthquake engineering. We have one of the world-renowned shake table laboratory facilities. We have the Western Superpave Center. That's one of the few niche programs in the country focusing on pavements and asphalt research. Our transportation systems group focuses on smart and autonomous transportation systems. And our environmental group focuses heavily on water and wastewater treatment, as well as water management in the arid West. So that is a good introduction to our program.
Thank you, Dr. Ryan. Our next panelist is from our Department of Computer Science and Engineering, Dr. Hand.
Thank you. Yeah, my name is Emily Hand, like the body part. I'm an assistant professor in computer science and engineering. I just started 2 years ago. Computer science is a part of everything these days. It's kind of wormed its way into every aspect of our life, especially now with all this craziness and working from home. It's no doubt then that the computer science department is growing all the time. In 2013, there were 12 faculty in the department. Now there's 25. And we have over 100 students graduating every year. We have a bachelor's degree in computer science, but we also have a ton of minors. We have a bunch of different specializations, including unmanned autonomous systems, cybersecurity, big data, and games and visualization. We have faculty who teach courses and do research in intelligent and autonomous systems, data and software systems, and cybersecurity and network systems. We have a cybersecurity center, which is interdisciplinary. So we have people from psychology and journalism involved in that. And we're working to introduce a robotics institute as well. As far as I go, I teach machine learning. That's my area. That's an elective that you can take in your junior or senior year. But by the time you're here, I'll also be teaching some core classes, including the Math of CS course, which is a required course that you'll probably take in your sophomore year. You'll see me everywhere, honestly. I'm involved in everything. I try to be a part of everything, but you'll likely see me in your second year in terms of classes. And for research, I do work in the area of machine learning, but specifically I try to build systems for people with autism or people with visual impairments to improve their social interactions. So that means we have to be able to understand language, so we can understand sarcasm and humor and be able to respond to it appropriately. And we also have to understand visual information like body language, expressions, and things like that. So yeah, that's it for computer science.
Thank you, Dr. Hand. Our next panelist is from the Department of Electrical and Biomedical Engineering, Dr. Fadah.
My name is Sami Fadah. I'm a professor of electrical engineering and chair of the Department of Electrical and Biomedical Engineering. We offer programs in biomedical engineering, which is a good way to go to medical school. You just need a few extra courses to make it to be eligible to medical school. We have a program in electrical engineering, and that has several tracks or emphases, as we call them. One of them is a general emphasis, which is very broad. It includes many areas of electrical engineering. Electrical engineering is a very broad field, it includes many things. And then the second track would be biomedical engineering also, which is a bit more electrical engineering than the biomedical engineering degree. The third is something we call RAVES, which stands for robotics, autonomous vehicles, and embedded systems, which is really more like microprocessors or little computers that we put in devices and control them with. And this is because many people don't realize that these areas are really interdisciplinary. But we have a good program in this area, a lot of people working on research problems related to them. And then we also have a degree in engineering physics. We also have I forgot to mention, there's an emphasis in renewable energy for people who are interested in power systems and electric vehicles. We have people working on research on electric vehicles, and that is related to an area called power electronics. And we also have another degree in engineering physics, which is sort of a combination of physics and engineering, and we offer it in collaboration with the Department of Physics. Regarding electrical engineering itself, well, you guys use lots of gadgets. Most of these are based on electrical engineering, as well as some of other things that you may not think of as electrical because they're in part mechanical. In fact, even computer science could be involved in them, like drones, like robots. So these are things that we work with. On the biomedical side, we have all kinds of applications of electrical engineering. Biomedical engineering, essentially, if you put together medicine and biology and engineering, you have endless possibilities. We have people who work with cells for ways of looking at cancer. We have people who are working with things for helping the blind. We have a person who has developed his own invention for detecting bacteria. So we have a whole bunch of research in our department related to biomedical engineering, as well as power systems. And as far as myself, my area is something called control systems, which is essentially how you make things like drones and robots do what you want. You need a control system to do that. That's all I have for our area.
Thank you, Dr. Fadah. Our next panelist is from the Department of Mechanical Engineering, Dr. Cao.
So hello, everyone. My name is Lei Cao, and so I am an assistant professor in the Mechanical Engineering department. And so about our department, so we're one of the 5 departments in the College of Engineering. And usually we have around 800 undergraduate students and also 40 graduate students. So currently our department has 23 faculty members, and we have 4 research disciplines. So the first one is deformation and strength of solid materials under loading. And the second one is the flows of fluids and the heat for power generation. And the third one is the control of systems subjected to the unpredictable conditions. And the very last discipline is an additive manufacturing of materials. So we have a strong cluster of faculty members. We'll use like 3D printer or laser processing to construct structural materials of such as metals and alloys and also polymers. So for the students in our department, we highly recommend that the student can gain some research experience with the faculty members in our department. And besides the current mechanical engineering program, our department is also studying an aerospace engineering program. So we already have 2 aerospace faculty members. And in the near future, we'll hire 3 more aerospace faculty members and also offering more aerospace classes. So besides the classes, we are also developing many projects, aerospace projects with in collaboration with local aerospace industry. So for example, the Sierra Nevada Corporation, which is a NASA contractor who is specialized in the nanosatellites and orbital services. So this is a brief introduction about our department. So in terms of my research group, we work on computational solid mechanics. And so the computational means that we do our simulations and predictions using computers. So we will use commercial available softwares and also research code that developed by our group to predict how the structural materials will change its shape and also will fracture under external loading. So the material we usually consider are metals and alloys and also ceramics. So we will study how the material change shape and how we can engineering the material to make it have a higher strength and also is harder to break. And that's a good introduction to our department and also the research topics.
Thank you, Dr. Cao. So our final panelist is from the Department of Chemical and Materials Engineering, Dr. Cantu.
Yes, hi, good afternoon. David Cantu, I'm assistant professor in the Chemical and Materials Engineering department. In our department, we have 2 majors, chemical engineering and material science and engineering. We also offer minors in renewable energy, in batteries and energy storage, as well as in nanotechnology. So chemical engineers look at the transformation of mass and energy, and they play a central role in providing products as varied as gasoline or cookies, ketchup or fertilizers, toilet paper or antibiotics. And material scientists and engineers look to design new materials with interesting properties such as super light alloys for airplanes or heat resistant materials for nuclear reactors. I teach chemical engineering classes. I teach all the chemical engineering and material science students in the sophomore year. And then I mainly focus on the chemical engineering senior classes. So the students, they mainly see me in the senior year, but most of them also in their sophomore. And my research is also computational, and in my research group we study rare earth elements, separation and catalysts, and also we use bioinformatics to study proteins and enzymes. And in my research group and in the department, there's always undergraduates participating. So thank you very much.
Thank you, Dr. Cantu. So you've heard from all our panelists a little bit about the programs in their departments. I'm going to now ask the panelists a few questions, and after that we will have time to take questions from you, the audience. Please type in your question into the Q&A box in Zoom that you will find at the bottom of your screen. And we may not have time to get to all the questions, but we will try to answer as many as we can. However, at this point, I'd like to introduce to you Meg Fitzgerald, who is our coordinator for recruitment and outreach. Meg, do you want to say hi? You might want to unmute.
Well, that would work so much better. Hello, everyone. Thank you so much for taking the time to join us today. We thought long and hard about how to interact with you. We were supposed to be in Las Vegas with you on this beautiful May 20th day, but considering all the circumstances, we obviously couldn't do that. So we decided to offer you this webinar. We want to make sure that we're answering any and all of your questions. I know many of you are still trying to make final decisions about where to go and or what classes to take. So we want to make sure that we are addressing any of the concerns or questions that you have today. So we're so glad you're with us.
Thanks, Meg. So Meg will be then compiling the answers to all your questions. So please go ahead and start entering your questions that you may have with relation to the engineering programs. So my first question is for the panelists: how hands-on are the College of Engineering programs?
If I can start, in our case, we have 4 required labs in our program, which is really more than many other electrical engineering departments, in addition to labs that you have in other courses such as physics and chemistry and biology for the biomedical group. On top of that, for several of our senior elective classes that are more specialized, there will be lab components or lab exercises as part of the class. For example, we have a class in something called microwaves, and there is a lab that goes with that class that is taught. Some of the time there will be a lecture, some of the time they will have a lab. And on top of that, you have like the course I teach at the senior level, I have a take-home exam that involves going to the lab and designing a control system and implementing it with an Arduino. So we do have a lot of hands-on exercises as part of our program.
I'll just jump in for computer science as well. So for computer science and engineering, it's like 100% hands-on. So I think there's only one class in the whole progression for computer science where there's no programming. So every other class, and it's a math of computer science type class. So every other class requires programming in some capacity. So you're going to be learning different languages, you're going to be programming different systems, either bottom up, right? Or you're just going to be adding modules, and you're also going to work with hardware in our computer engineering courses. And you have to take 1 or 2 electrical engineering courses as well. So you'll be working with hardware in those labs.
If I may add something I forgot to mention, which is that, and this is probably true of other departments as well, we have, as usual in engineering, we have a capstone design project which students complete at the end of their program. In our case, we have an unusual way of offering this class where students are organized into companies, and the students in the companies have to present a business plan. You see, many people don't realize this, but engineering has a business side to it. You cannot produce a gadget that's like, let's say you want to sell a cell phone, you won't be selling it for $10,000. Nobody will buy it. So you have to make sure that what you produce is at a reasonable cost. And so one of the things we have in the senior project is students are actually exposed to that side of things, and they have to present a business plan. They have to convince the instructor that this is something that somebody would be willing to buy. Then they have to build it and make it work. And Indira can tell you more about Innovation Day, which is a big event that we normally have at the end of the year.
And also I want to introduce a little bit about the hands-on aspects of the mechanical engineering department. So a lot of the classes offered in our department has hands-on labs. And we also have faculty members that will instruct the courses in the machine shop. And also we have a lot of the senior design project. So the half of the project is supported by the companies. So they will have a collaboration with the advisors from the company. So there's, for example, the Sierra Nevada Corporation, which is the aerospace engineering company. And also the other part of half of the projects will be supported by the faculty members in our department. So it will also be a lot of hands-on opportunities. And then there's a third aspect about a lot of the clubs offered. So for example, there's a vehicle clubs and there's a rocket club, and also there's a 3D printing club that the student is really interested in.
David, did you want to say something about chemical and materials?
Yes, we also have a lot of lab classes where students get to apply what they learned in their courses, and in their senior design in chemical engineering, they work with local companies to solve a problem. And in material science, many of their senior designs have been presented in like national material science conferences. So I think it's true for all majors. It is very hands-on, and they won't only learn the theory, but also how to apply it.
I'll keep my comments pretty brief. Civil and environmental engineering may be considered a little less hands-on than the other programs because it's harder to bring like the big infrastructure projects to life. And so the capstone is a lot of times going to be somewhat pen and paper, but we do, like the other programs, we have labs. In statics class, one of the first things students do is build a bridge structure from balsa wood. And then we have and mechanical engineers, and I think the materials engineers take that as well. And then we have the soils lab, the materials lab, and the water resources lab. So again, those are hands-on. Okay, thank you.
Thank you. I think I'm going to go to the audience questions now, because I see we have several questions and we'd like to get as many as possible answered. I'm going to direct some of these to specific panelists. So the first question I'm going to direct to Dr. Hand. The question is, what happens if you aren't in, oh, I'm sorry, no. The second question, what kind of computing language will most professors use when assigning coding projects?
So for the intro courses, there's a 3-course progression when you start. All of those are going to use C or C++. And that's because it's a really good foundational language. And if you know that really well, you can pick up other languages very easily. You'll also take a programming languages course where you'll learn a couple of other things like Java and some kind of weird languages like Prolog and Lisp, but that way you get an understanding of what those languages are like, because there's different families of languages. I teach in Python, but you don't learn Python formally in any of the classes, but again, you pick it up kind of along the way. And yeah, the C++ expectation is, let me just say, when I came in, I had never opened like a laptop, and I did okay. So there's no expectation that you need to know it at all. You can start from 0 or negative, I guess, in my case, and you'll be okay. So don't feel like you have to learn it before you get here.
Okay, I'm gonna go to the question on environmental engineering. What is the biggest pros in choosing environmental engineering over civil, or are both relatively similar? Dr. Ryan?
Yeah, I thought that would be mine. I'm biased, of course, since I'm on the civil side. I want to steer you to civil. But let's put it this way. I think the civil engineering degree is broader. So if you're uncertain, I would start in civil, and I would start getting a preview. And so some of the first classes you'll take are statics and then mechanics, and those are more on the solid side. And then you'll take the introduction to environmental engineering. And I'd say like a lot of the civil classes are more grounded in physics. A lot of the environmental classes are more grounded in chemistry as your background. So when I'm advising students, I often say, well, Do you like the solid side or do you like the water side? And if you find as you're starting to take classes that you really gravitate toward the environmental engineering classes and you want to focus in that area, that would be the point in time to say, I want to go for the environmental engineering degree. If you're still uncertain, then I would recommend starting out in civil and getting the broad background and seeing what you like. And there's plenty of time. There's really not, I mean, there's some differences between the two programs, but certainly if you take a couple of years or even into your junior year to decide, it's not going to harm you. I've had students ask if they could get a degree in both, and it turns out that you actually could, because there's not that much difference in the requirements between the two. Like you know, technical electives for environmental can required courses in environmental can count as technical electives in civil, and so on. So lots of room for specialization. Thank you.
And while we have you on the screen, Dr. Ryan, there is a question related to civil engineering. What are some of the things you learn or do in structural engineering?
So in structural engineering, it's two major aspects, I think, is the analysis process and then the design process. And they kind of go hand in hand. As a structural engineer, you know, you'll start with a design solution, and then you have to analyze it and see if it works, and then you iterate and so on. So when we teach structural analysis, that basic material is understanding how structural components and system respond under loads in various types of, like, their self-weight and people and cars and earthquake and wind. And so we analyze the stresses and the deformations in the materials and compare them to their limits. And then the design process is more about how the materials work and how they fit together, and the capacity side. And students will take design classes in, so if you want a broad background, you take design classes in all the different materials: timber, so your timber buildings, your steel buildings, and concrete. And we also have special courses in bridge engineering, which is more concrete, but bridge structures can generally concrete columns, but either steel or concrete structural superstructure deck systems. So I hope that's a good overview about structural engineering.
Thank you. I will now go to Dr. Fadali, a question on electrical engineering. So for electrical engineering, how many software tools / programs are needed on personal laptops?
Well, the main program we use is MATLAB. We use that a lot. Everybody uses it in most classes, and it's almost like a programming language itself. And we have a class where you learn about it, and that you can get through the university because we have a site license for it. And MATLAB, because it's, the thing about MATLAB is because it is sort of like a language, many universities have written their own little packages in MATLAB. So you have a statistics toolbox, you have all kinds of things, even some of them aren't even engineering. And so that's one of the languages that we use a lot. We also use C, because C is and C++, because C is the language that's used for a lot of the embedded systems for like Arduinos and these microprocessor things, so that we require. And I don't think you need to have anything in particular that you'll not be provided with by the university. So I wouldn't worry about it too much.
And Dr. Fadali, there's a question maybe either you or Dr. Hand can answer. Do you have to take digital design freshman year? It states that I need to have taken CS 135 as a prerequisite before I can take this class, and I was following the recommended schedule for freshman year and I got confused.
Yeah, well, you see, CS 135, I believe, is required for digital design, but so depends on how you're approaching this program. If you're able to take programming in the first semester, then you can take digital design and the digital logic design in the second semester. That's sort of the way the program usually goes. Now, some people are unable to take programming the first semester because they're doing remedial work, which is fine, as long as they're able to catch up. Eventually, there's no problem. Then these people wouldn't be taking digital logic design in the first year.
Okay, thank you. We're going to go to a question on calculus. Popular question. What happens if you are not in Calculus 1 freshman year? I'm going to take Accuplacer, but just in case. Meg, do you want to take that one, or do you want me to take that one?
I'd be happy to answer that.
Sure.
So we prefer you be calculus ready. All of the engineering programs require calculus as the entry-level math, but several of our students don't come in calculus ready. So it's great news that you're going to take the Accuplacer. And in case you're not aware of this, you can take it. Well, normally you could have taken it at the Southern office, but I believe you can do it online now. So Accuplacer is a great option, but you can also sign up for an online first summer session class that you can also take the prerequisite class to get to calculus. So if you're not in calculus, you could take, the Accuplacer or classes over the summer, or you can still come in the fall, not in calculus. You'll take the prerequisite class, but it depends upon your major, and that will determine if you're not calculus ready, it will slow down your progression to graduation. So that's why we really encourage the calculus, because calculus is a prerequisite for everything in the programs across the board, not just other calculus classes, but other classes in the required class outline. So.
Thank you, Meg. And there's one more question that you'll probably have the answer to. Are there any other forms you need to complete in order to get into Great Basin Hall?
So as long as you have applied for residence life, that would be the forms that you would need to complete. You would need to have contacted residence life. You would need to have completed the standard forms, and you would have needed to select Great Basin Hall as your residence hall option. I do know that Great Basin is incredibly popular, so the earlier you get your paperwork in, the greater chance you'll have of getting into Great Basin Hall. And I'm just curious, I know you can't answer this for me, but just food for thought, are you just trying to get in as a regular student, or are you trying to get in as part of our living learning community for the College of Engineering? So the living learning community is at capacity, and I heard that we have like a 50-person wait list for that. But if you're just trying to get in as a general student, you probably have a better chance of that, just so you know.
Thank you. There's a question on advising. Is there an engineering specific advisor I should speak to about my education? I will answer that one. Yes, we have 5 advisors within the College of Engineering. And probably what we can do is we will include the names of the advisors and their contact information. Meg, would that be the best way to do this?
So at the end, I have a slide with the website for the advisors, as well as their email and their phone number. So if the student has not already been in contact with our advising center, they can reach out to them that way. We also, just so they know, they'll be advised during their online orientation. So signing up for orientation is important, and you will be advised individually with an advisor from the College of Engineering for your classes.
And that should answer the question, who do we talk to about our class schedules? You will talk to your advisor during orientation. Okay, let's now go to a chemical engineering question. What is the biggest challenge for students in the chemical engineering program that they have to overcome? Dr. Cantu?
my biggest challenge to overcome, I would say that there are two classes where students, you take a materials and energy balance course, and there's in that course where a lot of students, most students decide to stay in chemical engineering, but that's the course where a lot of students decide to not take it. And then again, in the chemical engineering thermodynamics course, I don't know if there is a challenge that you could generalize to every student. I mean, there's most of the students that struggle in those courses, some of them overcome those struggles and they learn and they love the major, and others realize that in those courses that they don't want to do it, and it is fine. I think having a good preparation in calculus and physics and chemistry will help students be ready for those courses.
Thank you. We will get back now to some more questions on computer science. Dr. Hand will answer these. The first question is, what math level do we need to be in computer science, for computer science?
So I'm going to answer this, I guess, both ways. So the expectation is that you're coming in and taking Calculus 1 when you start. I think that's a pretty standard expectation for the College of Engineering. But if you're not, it doesn't mean you won't graduate in 4 years. You just need to make sure you get into calculus as soon as possible and you start taking the core classes. The highest level course that you have to take is linear algebra. And you'll usually take that sometime in your second year. But if you take one extra math class, you get a math minor. So most students get a math minor because they just take one extra class after that. And there's a wide variety of math classes at the 300 and 400 level.
Another question is, for computer science, what would be the best mindset to enter computer science?
So I love this question, but I also don't know how to answer it. And I would love it if you already posted it anonymously. So I would love it if you could just like clarify a little bit, because I don't want to just totally go off on a tangent, which I will do happily, but I don't want to not answer your question and go off on a tangent. So if you could please just try to clarify a little bit, and then I can try to answer that a little bit later, if that's okay.
Okay, and while it's being clarified, what would be the required courses in our freshman year to take computer science?
So for computer science, I mean, just like every other major, you're going to have your core stuff that you have to take. That's part of the core curriculum for the university, English, other things. For engineering, you have to take physics and a couple of other things. But as far as CS, in your first semester, you're going to want to take 135, which is the intro course. And then once you take 135, basically everything opens up to you. So then in the second semester, you're going to want to start taking your computer engineering courses, which would be digital design, CPE 201. You'll take CS 202, which is the second course in the progression. And then once you take CS 202, you can start adding electives in your third and fourth semester. But you want to make sure you get those out of the way, because those are required for everything else. And you want to take those in the first year so you don't get stuck missing a semester or anything like that.
And one more question for you, Dr. Hand. What computer/operating system do you guys suggest, especially for computer science and engineering?
So you're going to have the easiest time if you have a Linux machine or a Mac, just because you're not going to have to use a virtual machine or anything like that, because the expectation is that at least in your second year, if not in your first year, I can't remember if it's required in your first year, but you have to use a virtual machine because they want you to be working on a Linux environment. Don't worry, you don't have to ever have used one before. But they will teach you. But that way, if you have your laptop set up such that it has Windows on one side and Linux on the other, you can actually use it. The reason I say Mac is because it'll probably last you all 4 years and then some. I got a Mac before I started grad school, and I had it for 6 years before it didn't even crap out on me. It's over there. I just got a different one. So you'll have it for a long time, although it is a significant investment. But you can also get just like a Lenovo or whatever and put Ubuntu on it, and that'll serve you well.
And one more question for you while we're tackling, a lot of questions on computer science. When will I be able to declare a minor? I am majoring in computer science and engineering, but I also want to minor in digital games.
Okay, you can declare a minor, as far as I know, as soon as you start. So I think once you meet with your engineering advisors as part of the Engineering Advising Center, you can declare a minor at that point, and you can change it at any time or declare a minor at any time. I just had a junior come to me and declare a cybersecurity minor. So you can do it anytime. If you know you want to do it, you can declare it early. You just won't be able to take any of the classes that you need to satisfy the minor probably until your junior year.
Okay, thank you. Now we'll go to a question from Meg. I have been placed on the wait list for the engineering LLC. Is there anything that I can do to increase my chances of getting off the wait list?
I hate to be the bearer of bad news, but unfortunately, no. It's really on a first come, first served basis. And you don't want to wish anyone ill, but it's only if those who are already placed decide not to come would there be spaces that open up. So it's just a matter of where you are on the wait list and if people choose not to participate in the LLC when the fall starts.
And one more question for you, Meg. Does
Sure.
UNR have online classes for the prerequisite math classes?
You are in luck. So our first summer session is completely online, and we do offer the Math 126 and the Math 127 online this summer. So I know of students who are out of the area who are fortunate enough to be able to take those classes over the summer in preparation of taking calculus in the fall, or at least moving closer to taking calculus in the fall. So depending upon where you placed with your ACT and or SAT scores will determine where you place into your math, and will determine which math prerequisite class you would sign up for the first summer session.
Okay. Some more questions coming in. From my understanding, the freshman year of engineering will consist of more general engineering courses, and the second year is where you will begin to branch into your preferred engineering program. Is that correct? And yes, you are correct. You will be taking ENGR 100, which is the freshman engineering class, where all engineering students take that class. But for the most part, you get into your major courses in the second year. Does anyone want to add to that in case I did not state that right?
I guess we have to mention that in a lot of engineering classes, you need to know some background material in physics and maybe in math. So a lot of the freshman year, while there is an introduction to engineering class, and we have a follow-up class in our department in the second semester, there's a lot of time that you have to spend mastering the math and the tools that you need so that when you get to your upper division classes, you can handle them easily. Because a lot of the stuff that we do uses math.
And there's a related question on math. Can passing the AP Calculus exam help move us up in classes? Meg?
Yes. So yes, if you took the AP Calculus exam, and as long as you scored a 3, 4, or 5 on the AB test, you will receive credit for Calculus 1, which is 4 credits, so good job. And you'll place into Calculus 2 if you took the BC test and scored a 3, a 4, or a 5. You will receive credit for both Calc 1 and Calc 2, which is 8 credits of calculus, and you'll place into Calculus 3. Just a side note with that, if you just took the test this year, we will not receive those scores until about mid-July. So your current schedule will reflect your current placement. And it's only after we receive the updated scores for AP, will you be able to swap your classes? You'll swap out of the class you're currently in and swap into the class that you are eligible for. But yes, AP credit counts at the university.
Okay, a question for Dr. Fadali. When I first applied, there wasn't an option to pick biomedical engineering as a major. So I'm currently undeclared. Would I have to wait until my third year to major in biomedical engineering?
No, I think you can change major. I think Meg can even tell you more about changing major, but changing major is not a problem. You can do that quite easily. The only thing that you may have to do is that you may have to take the biology classes if you haven't already taken them. One of the things that are required for the biomedical engineering degree is the two biology classes, 190 and 191. And so if you've done these, you can change your major quite easily. There's really no problem with changing majors.
So just to add to that, Dr. Fadali is correct. There's no problem changing your majors, but just so students understand, all engineering students come in listed as undeclared with an anticipated major. And once we've determined your calculus placement, you must be registered in a calculus class. And usually during orientation is when you will actually be placed into your declared major. So it's a very easy process. There, you know, a lot of times students compare us to other schools where they make it much more difficult. At the university, we make it as seamless and as simple a process as we possibly can, as long as you are calculus ready.
Thank you. There's a question on internships and research opportunities. How will I be able to pursue internship/research opportunities at UNR? Is it possible to start an internship freshman year? I think I will answer that question. You know, we have a dedicated career services director in the College of Engineering. His name is Joe Bosick, and he works with students to find them internships. He has a huge database of companies that he works with. We have 2 job fairs every year, one in the fall and one in the spring, and we have over 70 companies that come to these job fairs to recruit our students both for internships and jobs. Freshman year, it is a little unusual for students to have an internship, but it is not impossible. My advice is to go to these job fairs, you know, check it out, see who's there and what they're looking for. Go and talk to the career services director, have him critique your resume and so on, and get prepared. Now, as far as research opportunities, there are many opportunities amongst our faculty in their labs for undergraduate research. And probably again, you may want to wait till at least your sophomore year to explore these opportunities. As you take classes with these faculty, you will get to know them, you will get to know their research areas, and I would suggest go and talk to them and try to get in. There is also funding available on campus for undergraduates to do research. Does anyone else want to add anything to that as far as internships and research opportunities?
I can add that we have several local companies that are very interested in offering internships, and internships are really a great experience for both the student, and in a way it's very useful for the company because very often these turn into jobs. We've had many people who went for internships with NV Energy or Sierra Nevada Corporation, which is another big company we have here, IGT, that turned into permanent positions. And so they're looking at the student is looking at the company, but even if you end up working somewhere else, this is a great opportunity to see how the workplace functions, and also it's something to put on the resume because potential employers look at it and say, well, this guy has or this gal has seen how things work in industry. They love that. So it's really recommended if you get that opportunity to do it. We also, in terms of research, I know that, for instance, we have had some students who worked with one of our professors who has a snake robot, which is I mean, there are several snake robots that are all over the world. There's one at Carnegie Mellon, there's some in Japan, but he has one that actually has some capabilities that are better than both. And so students have been able to work on that snake robot. There's also electronic braille, which is another thing that students have worked with. And so there are all kinds of opportunities for research.
Thank you. I think we have time for maybe 1 or 2 questions. There are a few we have not answered. One of them is, as for summer courses, what are the costs?
So I saw the question and I just looked that up. It's on our website. It's under our tuition and fees page. And the tuition for summer school classes for in-state is going to be $242.25. And then there's about another $50, $60, $70 in fees for the session. So it's $242.25 per credit. And then it's about another $70 for fees for the summer.
I think we'll take one last question, and this was a follow-up to the mindset question. I think that's what it's all about. It says, for computer science, what would be the best mindset to enter computer science? But that's, sorry for not clarifying. I meant when we enter the class of computer science, what are some things we should focus on?
So I'm going to try to answer both questions. So what I wanted to say before, but I wanted to make sure that you clarified first, was you need to go into computer science, and I think this is true in all engineering, with a growth mindset. So I took computer science because I had to, not because I was a computer science major. I was in a math program and you had to take CS. I went in there and it seemed like everybody knew what they were doing and I did not belong there. That's not true. A couple people have been gaming for a long time and maybe they took apart computers with their parents as kids. That was not me. That's not most people. So just because you don't feel like you belong right away because you don't understand the material, and this is, I think, true in all engineering, does not mean you don't belong. You really need to understand, like, you're not expected to be an engineer when you come and start taking engineering courses, right? We're going to teach you that. You're going to be that when you leave. So you need to make sure, like, you understand it's not going to click right away, and that's okay. But eventually it will, and it'll be awesome. So what you should focus on, and I think this is true for all engineering classes, I think you need to make some friends, because it's not something, you cannot just go through the engineering degree by yourself and just tough it out. You need friends, you need study groups, you need people to help you. And you also need to, you know, don't focus so much on just like exams, right? Don't focus so much on just programming. You need to understand the concept at a high level and be able to talk to somebody about it. So don't get, you know, you need to see the forest through the trees, right? So don't get stuck in the trees, if that makes sense. I hope that was helpful.
Thank you. We will take one last question. Is it possible to have more than one minor? And I believe, Meg, you wanted to answer that one.
I'd be happy to answer that one. So students can have as many minors as they have time to complete. As Dr. Hand pointed out, if you are a computer science and engineering major, you only need one extra class to get a math minor. And it also depends upon what's your major and what classes have you already taken. And those classes, in many cases, not all, but in many cases can, what I call, double dip. They will count for your major as well as count for your minor, which is a really nice gift. But let's say you decide to take a minor in something completely outside of engineering. You're going to be a music minor. You would need to take all of the classes for that minor. So it'd be separate from your major program. But you can have as many minors as you would like to pursue.
Thank you. I think we've just about run out of time, but I know that Meg wanted to share a slide with you all, showing you some additional resources. So I'll let her do that.
I'm hoping I'm doing this right. Can you guys see the slide?
Yes, I know.
Perfect.
I can. Yeah.
Yay. So yeah, I just wanted to list a couple of the primary resources for you students. There's the UNR homepage. Our website is incredibly packed with information and resources for you. If, you know, again, unfortunately, we can't be with you in person. We are offering virtual tours. And this is the link, but it's also on our homepage at the top. If you have financial aid and scholarship questions, they are available to answer those questions for you. There is the link to their website. Same thing with residence life and housing. As we already mentioned, orientation is being moved online for this summer, but you will be meeting with an advisor from the College of Engineering. And then separately, if you need to contact the advisors prior to orientation, there is their information. There's the website where you can get their information and see pictures of the advisors, but they're going to refer you to the email, cohenadvising@unr.edu, or you'll need to call and leave a message and someone will get back to you to schedule an appointment. So we want to make sure you're getting all the tools that you can possibly need.
Thank you, Meg. I would like to thank all who attended this webinar, and thank you for all your questions. They were good questions, and we are all on campus to help you when you come to campus as freshmen. So we look forward to seeing you there. Thank you all. Bye.